The third characteristic of sound you should know is the speed. Sound travels at approximately, we're going to use 340 meters per second. In air, which is what we live in unless you're a fish, at room temperature, and I'm putting quotes around that, I'm approximately going to say 20 degrees Celsius. Again, we're just giving about figures. So I want you to remember that number, 340 meters per second, at room temperature in air. It changes if we change the temperature or if we change the medium, and we'll talk about that soon. That's pretty fast, according to you and me. It's 760 miles per hour. There's no way you can run that fast, but I do need to tell you right now, in terms of sound even, that's about as slow as you can get with sound, almost as slow as you can get. Sound traveling through other materials goes way faster. And on the scale of waves that travel, the speed of waves in general, like light, it's really, really slow. But we do use that sound, and you need to know it, 340 meters per second. We use it most often when we're looking at storms, all right? So there's a little illustration here that I want to show you. You're outside, you're watching a lightning storm. Maybe you've done this before, and you want to know, I wonder how far away that lightning is striking. Well, turns out there's a way to do that. Maybe you know this. So when you see the lightning, it takes a certain amount of time to get to you, and then you hear the thunder later. All right? So I'll play that back again. That white line will represent the light traveling to you, and the light gets to you basically instantaneously. It's not exactly instantaneously, but the point that I want you to see is that it takes the sound a lot longer to travel to you, and the reason is because the speed of light is 300 million meters per second. If you can see lightning, that light is getting to you practically instantaneously. Whereas the speed of sound is only 340 meters per second, as we said a minute ago. That means it takes approximately 5 seconds for that sound to travel the distance of 1 mile. So what that means is if you count from the instant that you see the lightning, count the number of seconds until you hear the thunder, because in case you didn't know, thunder is the sound that lightning makes when it goes through the air. If you count 1 second, that means that lightning struck approximately a fifth of a mile away. Maybe you could even round that off to a quarter of a mile away. That's about 3 football fields, by the way, so that thing's pretty close, right? 3 seconds, you got 3/5 of a mile. If it's 5 seconds, you got 1 mile. So all you got to do is count the number of seconds it takes for you to hear the thunder after you see the lightning. So lightning strikes, 1, 2, 3. You hear the thunder then? Well, that's 3/5 of a mile away. So take the number of seconds and just divide it by 5, and that'll give you the approximate number of miles to the storm. Next thing I want to do is show you, the next video here is a great video from Mark Rober about how slow sound is in air, actually.